I'm hoping today that we can show the benefits of using the new bale-tight system in combination with the wrap, where we get a better oxygen barrier and a better mechanical barrier during the bale making process. In comparison to the net wrap, we have now a film wrap that enables us to have an extra oxygen barrier during making the bale, and this will help to remove oxygen more quickly. Also, it squeezes the bale a little bit tighter than the traditional net wrap, and so we actually squeeze oxygen out of the bale. And oxygen is the biggest problem when making and storing silage. So the quicker we remove oxygen and the longer we maintain an oxygen-free environment, the better we have a better fermentation process, so we get better silage quality, and also we reduce the risks of moulds. And so with the bale-tight system, we actually have the ability to cover the edge of the bale, and we have a better seal with the film coming onto that than the traditional net. And because of that, we have an oxygen barrier over the whole circumference of the bale, where we have the fewer layers of wrap, and so we should get a better seal on that bale, reduce risks of oxygen. In addition, we will be looking at we'll weigh the bales, and we will look at losses during the fermentation, and so we should be able to see whether we've had better fermentation quality, actually reducing the dry matter losses. Because it's a film next to the silage, when we're unwrapping the bale for feeding, there is no chance of silage actually getting incorporated into the net. We have no problem with that with the film. And also, because it's made of polythene, it can be recycled with the film wrap. When we're handling the bales, because we have now this film covering the bale rather than a net, it is our feeling that there'll be better mechanical handling properties of the whole bale. In addition, and it is just a feeling, but it's something that we'll hopefully be looking for, is that if there is damage to the wrap, our feeling is that because we now have a film inside there holding the bale together, that actually with the wrap on top we'll get a better seal, less risk of oxygen penetrating into the bale then as well. So overall, we're hoping we'll have less mould coverage and better silage quality. Today we're going to look at how the different treatments, the bale-tight versus the net wrap, have affected the silage quality. Just before we move the bales, we take a pressure test. This enables us to, basically we take a vacuum into the bale, and then we allow the air to penetrate naturally through the seals on the film, and we take the time it takes for that vacuum to disappear, so return back to atmospheric pressure. And again, this tells us how good the bale seal is. And all the time we're looking for reducing the oxygen penetration into the bale, which then will have an effect on mould coverage, so the two should tie up together, also dry matter losses, and hopefully also silage quality. We're going to look at how the different treatments have affected the silage quality in terms of chemical composition by taking a core sample from every bale, and also looking at the losses through weighing the bales. We took the bale weights when we harvested the silage, and now we weigh again, the difference being the losses in silage, and also the coverage of mould on each bale, so that we can make an assessment of how much mould and whether the two treatments were different in terms of the mould coverage. In the lab, we're doing a standard near-infrared spectroscopy, which is the standard analysis that a farmer will get. It will give the range of energy, protein. I don't expect big differences between the two treatments for that, because that's more a gauge of how good the grass quality was at harvest. Where I am expecting some differences is in things like ammonia and the volatile fatty acids and lactic acid and pH, where with the better fermentation, hopefully we'll have a better proportion of lactate to acetic acid, and the better fermentation, if we've got a better oxygen barrier and a denser bale, we should have that better proportion of those lactate acids compared to the other acids. And the other thing would be the sugars, which are affected by the crop quality but also by the fermentation. So if we improve the fermentation, we would expect the sugars to be higher as well. The results have enabled us to look at the factors that we wanted to, because it was set up as a scientific trial but conducted in a real farm situation. The first thing we noted was that the crude protein, the metabolizable energy, the ash content was very similar across all bales. So what we can firstly say is that the grass in the two different treatments at the start of the experiment was more or less the same. The next thing we found was that there was a slight difference in the dry matter content of the silages. So the F&F system was drier. And this is because where we have a better fermentation, we don't produce so much water during the fermentation. So actually we've retained more of the nutrients. We look at the pH, and the pH was very similar between the two, maybe slightly lower on the F&F system compared to the net system. But to get to that pH, we need to produce acids. And what we found was we had lower acids in the F&F system, but got to the same pH. And it's the pH that controls the spoilage. And we did that by producing less acids. When we look at the sugar and the ammonia values from the silages, we found higher sugar on the F&F system and lower ammonia, meaning that we preserved the protein and the sugars better, where we'd reduced the oxygen penetrating the bale and improved the silage quality. In the past, in bale trials, we've just looked at mould coverage on the bales. In this trial, we decided we would actually remove any mouldy silage and weigh it so that we could get an accurate assessment of the mould weight. Moulds need oxygen to grow. Without oxygen, they won't grow. So what we found was with the F&F system, we had on average across those bales within the trial group 5.5 kilograms of fresh matter silage wasted because of moulding. Whereas with the net system, we had 24 kilograms fresh matter of silage wasted. So that's a 5-fold increase in the amount of mouldy silage with the net system. The pressure test tells us how quickly air repenetrates the bale after it's been removed. And with the F&F system, it took 180 seconds on average across the bales for the air to come back in, whereas with the net system, it only took 20 seconds. And this just shows that there's a 9-fold benefit in terms of air coming into the bale reduced with the F&F system compared to the net system. The trial being conducted on a commercial farm, but being conducted with scientific vigour, enables us to actually look at the real farming practice and the benefits of such a system under those conditions. Many trials are conducted on research farms where everything is done absolutely correctly and there is less risk from mechanical damage. And the F&F system is a system that really lends itself to real working conditions where damage just happens on farms. It's very difficult to avoid damage. So this shows us that if you can manage that system correctly, low oxygen penetration, because you don't damage the bales, you have less risks of moulds. Oxygen really is the enemy of silage making. If we have oxygen, we have problems. And all the trial data, right from the first pressure test, where we showed bigger benefits with the F&F system, through to lower mould amounts with the F&F system, through to better fermentation quality and more sugar and less ammonia nitrogen, are all related to oxygen. It's very clear to me that by reducing this oxygen with the new approach, we can improve the quality and the quantity of silage we have to feed.